How do we add and subtract these radicals? These are square root numbers here. How does this work? Well, 3 root 7 plus 2 root 7, you know if it was algebra, if I said, well, what's 3 apples plus 2 apples, you would say that is 5 apples. So 3 root 7 times, or plus 2 root 7 is going to equal to 5 root 7. People say, that's it? That's all you do? Well, it gets more complicated depending on what you're looking at, but that's the basic rule. If you have matching radicals, you can add these outside numbers, these coefficients here. Let's look at a few more random problems here. This will give you a good idea on how we do this. You look at a big problem. You ask yourself, are there matching radicals, matching square roots? Well, sure, we can imagine this like a 1 root 3, and that matches with 3 root 3. So what are we going to do? Add them up. That's 4 root 3. The square root of 3 is not going to go anywhere. It's going to stay just right there. Cross them off when you're done if you like. I'm done with this, cross it off. Done with this, cross it off. Then we can clearly see where we go next. Negative 4 root 5 plus 1 root 5. Negative 4 and a positive 1 make negative 3 root 5. Notice I still got a square root of 3, I still got a square root of 5. That's it. When you have no more matching terms, that is the answer. We never subtract anything under the square root sign. Problem done. What if there are no matching radicals? Well, you first got to make sure everything's simplified. 2 root 18, you look at that number 18, and that looks suspiciously like a number that might be divisible by one of our famous square numbers. 1, 4, 9, 16, 25, 36, and so on. You can probably already see it. Square root of 18 is 2 times 9. So here's what we'll do. We will take this 2 right here, leave it outside, but then inside the square root of 18, I will change to 9 times 2. 4 root 2, I can't simplify that. Square root of 2 is as simple as it gets. What do I know? I know the square root of 9 is 3. So that 3 is coming outside the square root. What's going to happen with this 2 and the 3? These are going to multiply here. Everything out there is multiplication. I don't see any plus or minus sign out there. It must be 3 times 2. So here's what we will see. We will see 3 times 2 is 6. Root 2, that square root of 2 is still in there, right? And look at that. Now our square root matches. Plus 4 root 2. 6 plus 4 is 10. Square root 2 stays the same. There's your answer. What about a big problem like this? The first thing to do here is to check and see if you have any perfect squares under your square root sign. So if you think about this list, you say, hey, that number 16, it's already up there. That number 49, it's already up there. So we know some square roots already. I know the square root of 16, and I know the square root of 49. That means we're going to multiply a 4 out here. 4 comes outside, negative 4 is already there, we multiply it. What's going to come outside here? 7. 2 is already there, we're going to multiply it. And over here, the square root of 72, I bet that 72 is divisible by one of these perfect squares. So, let's see, negative 4 times 4, that makes negative 16. What's left under my square root? It's an x. Down here, 2 times 7, that's plus 14, square root of x, minus, and here's what we have to do a little thinking about this 72. It's divisible by more than one of these perfect squares. I'll do what people normally do here, and they see that 72, and what they think of is 9 times 8. 9 times 8, and of course we've still got that x under there. What do we know the square root of? The square root of 9. So we'll write this whole line over. It's one line, one step of math here. We get negative 16 root x plus 14 root x, we'll add those in a second, minus 3 square root 8x. But are we done, of course? Well, this number 8, you just have to catch it here. You look up here and you notice, hey, 8 is also divisible by 4, so I have to do that process again. It turns out 72, if you're really good, you might have noticed that that is 36 times 2. But a lot of people don't realize that, and you'll get the right answer just the same. It'll just take you an extra step. One extra step is not a big deal. Negative 16 square root x plus 14 square root x minus 3, and now that 8, I'm going to imagine, is 4 times 2. Of course, our x is still there. It's probably problem's just kind of dragging on, but it's important to realize what's happening here. This might happen to you. If you don't guess the biggest square root, we're going to have another step on here. Square root of 4 is 2. It's going to multiply that negative 3. So let's do it here. We have negative 16 square root of x plus 14 square root of x. And now we have minus 6 times the square root of 2x. And we think, which square roots match? Our negative 16 root x and our positive 14 root x. So we can put those together. Negative 16 plus 14 is negative 2 square root x minus, can't do anything here, it's just going to be 6 square root 2x. That is the answer. Craziest answer we've ever seen. But I don't see any matching square root signs, so the problem is done.